On your calculator, I want you guys to find this button. So I know it doesn't really make sense to you guys. Like, would it make more sense for it to be NL for natural log? A lot of the math we do comes from different languages. So, and whoever invented this, that's what they used. So we're just gonna go with that. To write ln, we usually write this, cursive L and then N. Because if I do this, that looks like a 1, right? So whenever I do ln and whenever you guys do ln, you should make a cursive L, so that way we can differentiate between the two. Okay, so the definition, for x is positive, y is equal to the ln of x, if and only if x is equal to e to the y. So if you guys notice on your calculator, isn't there an e in the corner? And there's a reason for that. What did I tell you guys yesterday is the relationship between most of the buttons. They're inverses. So this should tell you that ln and e are inverses, which we'll talk about here in this box. Okay? So this stands for natural log. So if we're given f of x is equal to log base e of x, that's the same thing as ln of x. This is called the natural logarithmic function. So note that the ln of x is the same thing as a log with base e. We never write it like this. Whenever you see this, this means that the base is e. Is everybody on board with that? Just like when it's log of x, if it's just log of x without a base, what was the base? 10. If it's ln of x, the base is always e. Okay, we just don't write it. So I would highlight that if I were you guys. So here in America, we say ln of x. I follow this little Australian guy on TikTok that does math problems. In Australia, they say ln of x. If you guys want to say that just because it sounds funny, I'll probably smile and be like, okay. But we say ln of x, like we pronounce the letters. Therefore, because y equals ln of x and x is equal to e to the y are equivalent, then the functions f of x equals e to the x and g of x equals ln of x are inverse functions of each other. I need you guys to know this because otherwise the next section or 2 sections from now will not make any sense. All right. So let's practice using our calculator. So we're going to use a calculator to evaluate the function f of x is equal to ln of x plus 2 for each value of x. Round your answer to the nearest 3 places. All right, guys, you guys ready? So real quick, this means we're gonna plug in 2, right? So this is what I want you guys to understand. Your calculator is very smart, but it will only do what you tell it to. So if you want to find f of 2, that means that I'm plugging in 2 for x. You guys with me? So if you do it like this, ln, if you type in the ln button on your calculator, do you guys see how it automatically opens up parentheses? Okay, so the ln of 2, now this is important. If you don't close the parentheses on your calculator and you just keep typing +2, your calculator is gonna do, everyone pay attention, your calculator is gonna calculate the ln of what's 2 + 2? 4. The ln of 4 is not the same thing as what it's asking you to do. So if you guys look at our function, what you're really finding is the ln of x in parentheses, then take that answer and +2. Okay, so you have to close the parentheses right here. Otherwise, it's gonna give you the wrong answer. Okay? So parentheses matters. So if you do that, talk to me. Did we get 2.693? All right, cool. And that's all you have to do. Bless you.
Thank you.
B. So f of -1 is equal to the ln of -1 + 2. What does your calculator say? There's an error. Did we do something wrong? It's negative. This is a natural what? A natural log. So it's still a log function. Remember, you guys learned that for logs, the domain has to be positive. Okay, so I can't plug in a negative value into this function. Okay, so what do we say for our answer then? Does not exist. Okay, let's do a weirder one. C. So this is my x value, so that goes into my parentheses. So f of 1 plus square root 5 is equal to the ln of 1 plus square root 5. If you guys hit the right arrow, it'll get out of the square root, so that way you guys can close the parentheses. And then take that and add 2. Yes. Okay. If you guys did not get that, it might have just been you didn't get out of the radical. Okay, questions? Okay. We have 3 more examples, guys, but they're all quick, I promise. Okay. The next thing we're going to talk about is some properties. So some important things. Ooh, whoa. Calm down. My iPad went a little crazy. Sorry. Couple properties. All right, you guys good? The following are important log rules to remember that also apply to any natural logarithmic function. Remember that the ln of x is the same thing as a log with e as its base. So the natural log of 1, remember, what's the base? E. So I'm going to write in just a little e here to remind us. The natural log of 1, so e to what power would give me 1? 0. If you have an exponent of 0, anything, because remember, e is like 2.7 something, anything to the 0 power is going to give me 1. Okay? So that's true because e to the 0 power is 1. Okay. The ln of e, so e to what power would give me e back? 1. That's because e to the first power is just e. Okay. ln of e to the x. What's the relationship between natural log and e? They are inverses. So what's going to happen to the ln and the e? They cancel. So this is just x. And similarly, e raised to the power of the natural log of x will also be x. This is important because this is how we're going to solve problems in section 5.4. Okay. If we have the ln of x and that's equal to the ln of y, that means that we can drop the logs and say that x must be y. Okay, so next problem. Okay, so this one's a little tricky. So I'm going to rewrite it. The ln of 1 over e. Remember, I hear some of you guys typing on your calculators. Does this say anything about rounding here? So I don't want any decimals for this answer. So remember, what's the base? E. Okay. One thing I want you guys to remember is we talked about negative exponents in the warm-up, right? So do you guys agree like 1/2 is the same thing as 2 to the negative 1 power? Does that make sense? So 1 over e, therefore, is the same thing as e to the negative 1 power. So remember, the answer to any log question is the exponent that makes this true. So e to what power gives me 1 over e? Negative 1. So this is just negative 1. Okay, B, e raised to the ln of 6. So remember, what's these two relationships? They are inverses. So what's going to happen to them? Cancel. So the answer is just 6. There's no work to show for that because I assume that you guys know that they're inverses. Okay, so don't stress like, I didn't show work. What do I do? It's just, I hope you guys know that. C. 5 times the ln of 1. This is one that always comes up in calc. And you guys just wrote it down. What's the ln of 1? 0. So this is the same thing as 5 times 0. which is just 0. Okay, guys, what's the base? E. So this is the same thing as 9 times the ln of base E of E. So remember, the answer to any logarithmic problem is the exponent that makes it true. So what power do I raise this to get E back? 1. So this whole thing right here that I'm circling is just 1. So this is the same thing as 9 times 1, which is 9. Okay, and if you guys look in the box, you guys are honors, so hopefully you guys do this. I don't just give you guys definitions just to make you guys write them down. I hope that you guys go back through your notes and actually look at your definitions, because then everything should be pretty much straightforward. Please look at your notes. This is in that box, right? So even if you guys didn't know what to do, you're like, oh, he gave us that. That's 1. 9 times 1, okay. All right, 2 more bumps. Domain. All right, remember, we can't take the log of what type of numbers? Negatives. So whatever's on the inside, we need the inside to be positive. So the domain of any log function, the inside, the x has to be positive. So in this problem, we have x minus 3. So we need the inside, the x minus 3 part, to just be positive. All you have to do is solve and then write it in interval notation. So to get x by itself, do you guys agree we can just add 3 to both sides? Which means that x has to be bigger than 3. Okay? If x is bigger than 3, then it's not underlined, right? So bracket or parentheses? Parentheses. So the domain of this problem is just going to be 3 to infinity. Okay, same idea. We want the inside to be positive. So we're going to say that x plus 4 is greater than 0. Subtract 4 from both sides. So we get that x has to be greater than negative 4. Which tells us that our domain is what? Yes, negative 4 to infinity. All right. Questions, guys? Does this make sense? This obviously makes sense, right? Hopefully, because you guys are seeing it over and over again. Please don't forget this because this comes up a lot. Logs have to be positive. Don't forget that, please.
So when I was like, we were trying to cancel out a log. For example, we would like to example one. So since like those logs, like log 4, you cancel out like 4. If it was like a log, would I cancel out by a 1?
If it was just what? A 1?
Yeah, like and then
What is 1?
because there's log 4, and you cancel out by. It's a remember. I mean, actually, VUB better. So log 3, and you cancel out by 3. So if there was no number right there in this log.
What's the base if there's no number there? 10. So you'd have to do base 10 on both sides.
Yeah, that's it.
Okay. All right. Do you guys have the word problem? Is it a cutout? It talks about psychology experiment. Okay. I also want to make sure I didn't make you guys write it down. It's a long one. All right. Last problem. You're good. So this says students participating in a psychology experiment attended several lectures on a subject and were given an exam. Every month for a year after the exam, the students were retested to see how much of the material they remembered. The average scores for the group are given by the human memory model function. So for our problem, that's what we're focusing on. F of t is equal to 75 minus 6 times the natural log of t plus 1, where for our case, t is between 0 and 12, where t is time in months, okay? So, for example, most of you guys are juniors, right? What's a class that you guys took freshman year that you guys haven't looked at all since your freshman year? Biology, right? Biology? So if you guys were given like a biology test right now, do you guys think you guys would get an A on it? Some of you guys might, okay, if you guys really like the subject, but like for me, like I know a lot of you guys are taking AP chemistry. If I were given a chemistry test right now, I would for sure fail it because I don't remember a lot because I haven't taken chemistry in like over 10 years. It's been a long time, okay? So what are you guys gonna think the longer time that passes between them finishing the class and they take a test, what do you guys think are gonna happen to their scores the longer they wait? Are they going to score higher over time? No, they're going to score lower. So let's see what happens. Okay? So for part A, what was the original score on the exam? So original score, if we're talking about time, how much time has passed if we're trying to find like the original score? 0, right? So time t is equal to 0. So t stands for time. I'm going to plug that in for t. So f of 0 is equal to 75 minus 6 times the natural log of 0 plus 1, which is equal to 75 minus 6 ln of 1. Okay, I know that you guys want to jump straight to your calculators, but this one we can actually do without a calculator. What was the ln of 1? You guys remember? 0. So 0 times 6 is not just 0. So 75 minus 0, that's just 75. Okay. B. What was the average score after 8 months? So what do you guys predict? Their score is going to go up or down? Down, so let's see. So f of 8 is going to be equal to 75 minus 6 times the ln of 8 plus 1, which is 75 minus 6 ln of 9. This is ugly, so you do have to use your calculator for this one. And it's going to give us a decimal. Go ahead and round to just one place. 61.8.